This video is going to cover the topic of graphing ratios. Be sure the date and topic are at the top of your page. The essential question of this video is how can we represent a ratio on a coordinate graph? We have worked with coordinate graphs before, and this video is now just going to show us how we can use coordinate graphs as a way to display a ratio or a rate. We'll just do a few friendly examples to show how that might look. So let's say in a community, the ratio of dogs to cats is 2:1. So for every 2 dogs, there is 1 cat. We can also, of course, write that as a ratio of 2:1. I'm going to make a quick table that shows this ratio. This relationship can also be displayed in a coordinate graph. I've started by drawing my axes. So here's my x and here's my y axis. And I'm going to label the axes so I know which side represents dogs and which represents cats. As we'll see later, sometimes we need to be particular about which group is the x and which is the y. But in this example, we'll just go ahead and put the dogs here along the x. And we'll put the cats along the y. Now I'll go ahead and mark my numbers so I know what my scale is. This, of course, is my origin of 0, 0. And I think I'm just going to count by ones again here. So I'm just going to count up by ones. And I'll do the same thing for my cats. I'll also give this a quick title. I think I'll just do the title of ratio of cats and dogs. And actually, I think I'll do ratio of dogs and cats since I started with the dogs first. I'm going to just make that change, ratio of dogs and cats. From there, I can start plotting my points. And looking back at my table, I can see that the first information tells me that my dogs, which is my x value, is 2, and my cats, which is my y value, is 1. So I can go ahead to 2, 1 and mark that point. The next coordinate point would be 4, 2. The next coordinate point will be 6, 3. And the last one that I've written here is 8, 4. So I'll just go ahead and plot that as well. This graph is useful because I can use it to predict or determine the ratio or the value of my ratio if I scale the information up. I'm not going to actually draw a line here, but if I could, let me just do a little light faded line. If I could, I would see that there's a trend and that's going to keep going so that the next number would be 10, 5, right? And it would go right here for 10, 5. Right? And if I had more room, I could stretch this out even further to see what the numbers would be if I kept this pattern going. We can also use this when we are looking at the ratios or proportions for measurements. We measure liquids and some solids in cups. We also measure them in pints. We would need to know then that there are 2 cups in every 1 pint. Again, I think I'll make a quick table of this ratio just so I can see the connection between pints and cups. So if there are 2 pints, if there are 2 cups, there's 1 pint. If there are 4 cups, there are 2 pints, and so on. And I could keep this going as long as I needed to. But then we can also express this in a coordinate graph. So go ahead and get your axes set up. I'm going to do the same here. You might have noticed that I often put arrows at the end of my axes. It's because these lines could go out to infinity. They could keep going as long as you needed them to. But in the meantime, I'm only going to stop right there with my little arrows. So I have my x-axis and my y-axis. I'm going to go ahead and use my x-axis for cups. And I'll use my y-axis for pints. From there, I'll just go ahead and mark my origin. And then I'm going to count, I think I'm just going to again count by ones here. If my values went up really high, I might decide to count by 2s or 5s, but ones is fine here. And again, for pints, I think I'll just count by ones. And I just went ahead and titled this graph Ratio of Cups to Pints. You might have a more creative title that fits this as well. but I'm keeping it pretty basic. So the first point I'm going to need to graph is my x value, which I've determined to be my cups, of 2, and my y value of 1. So I'm plotting the point 2, 1. So I'm going to go ahead and mark that in. From there, I have the point 4, 2, right? X comes before y. Then I have the point 6, 3, and so on. So go ahead and make sure you have all of your points plotted. Just going to go ahead and plot my points while you do that. And in this graph, if I wanted to, I actually could connect these dots. The last time I said we couldn't, but this time I'm saying that we would be able to if we'd like to. Do you know why it is different, or what is different in this graph than our first one? If you are thinking that the difference is that there are values that are possible between the whole numbers here, you're right. Cats and dogs don't have fractions or partial pieces, but we can have a partial measurement of a cup and a pint. We could have 1 56/100 of a pint if we wanted. So I can connect those lines, connect the points to show that there's value in between each of those coordinate points. We'll be able to talk more about that as we get more into graphing. For your turn, let's take a look at this ratio of flour to yeast for 3 cups of flour for every 1 tablespoon of yeast. And you can go ahead and create yourself a little table to record some data, and then I'd like you to graph it just to get that practice going with graphing ratios. And of course, the essential question for this video was, how do we represent a ratio on a coordinate graph? And that's what we'll be practicing more together in class.